So in this video, we are looking at sketching quadratics by completing the square. We've covered completing the square in the previous video, so this is assumed knowledge for this particular technique here of graphing. Now, what I've got here in the key ideas is that for a quadratic in the form of y equals a, which is just some coefficient that dilates the graph, outside of x minus h squared plus k, you may recognize this form from when we completed the square. We can read the vertex from this equation as h being the x coordinate, this one here, and k being the y coordinate. And this is why sometimes we call this vertex form of writing a quadratic. Now we're going to go straight into completing the square and actually sketching a quadratic here. So this first graph here, y equals x squared minus 4x minus 5. We already know that the coefficient of x squared is positive, so this will be a concave up parabola. Now, we're going to just find a couple of sort of key features first. Now, just by looking at it, we can already see the y-intercept. If we subbed in 0 for these x values, that will cancel these two terms out. So our y-intercept is going to be negative 5. So we're just going to label that in before we do anything else. We anticipate it's going to pass through here. Now, we want to, from here, complete the square. So y equals to x squared minus 4x. We're going to add that coefficient of x, divide it by 2, and square it. And remember, we can't just add something out of the blue, so we have to subtract that then again, and then minus 5 from that. So what we're going to get is x squared minus 4x plus 4 minus 4 minus 5. This bit is our perfect square. So we have x minus 2 squared minus 9. So this is our equation in vertex form. Now from here, we can read off where our vertex is going to be. Now this h value, because it's currently in this form, this h value is going to be 2. The k value is going to be negative 9. So that means our vertex is going to be at the point 2, negative 9, which is all the way down here. Now, what we also want to do is we want to find the x-intercepts. So we found the y-intercept, the vertex. We also need to find the x-intercepts. And we get these when we set y to equal 0. So for the x-intercept, 0 equals x minus 2 all squared minus 9. And now we just have to solve the equation. So if we add the 9 to the other side, we get x minus 2 squared equals 9. And then x minus 2, if we take the square root, is going to equal either positive 3 or this is going to equal negative 3. These are our two solutions. So for this one, we get x equals 5. For this one, we get x equals minus 1. So these are our two x-intercepts, one at negative 1 and one at 5, which should be here. Now that we have all these points, we want to label our vertex, remember. So this is going to be the coordinate 2, negative 9. And we're going to draw one continuous curve, passing through each of these as best as we can. And we get this graph here. This is our graph of y equals to x squared minus 4x minus 5. Completing the square allows us just to read off the vertex really easily, and it's going to help with the accuracy of our graph. Now, this is when we got some nice x-intercepts. In the next example, we're going to see an example with surds. So if we get this one over here, y equals x squared minus 4x minus 1, we're going to complete the square. So actually, before we even do that, we can immediately read off the y-intercept. If we sub in 0 for x, that'll give you 0 squared minus 4 times 0. These two terms will cancel out, giving us a y-intercept of negative 1. We also know that the coefficient of x squared is positive, so it will be a concave up parabola. Now we need to complete the square. So we set y to equal x squared minus 4x plus that coefficient of x over 2 squared. And then we subtract that because we can't just add something out of nowhere. We have to cancel that out because remember, we're just writing an equivalent equation just so we can write one bit of it as a perfect square. So our perfect square part of this is x squared minus 4x plus 4 minus 4 minus 1. So I get y equals to x minus 2 squared minus 5. And from here, we can read off our vertex. So our vertex is going to be at the point here, 2, negative 5. So 2 and then negative 5. 2, 3, 4, 5 is down here. We'll label it. And of course, this is going to be a minimum turning point because this is a concave up parabola. And now we want to find the x-intercept. So we're going to find this by setting y to equal 0. So I get 0 equals to x minus 2 squared minus 5. Now, we want to rearrange this, so we're going to add 5 to both sides. We're going to take the square root of both sides to get rid of this squared. So I'm going to get two answers here. X minus 2 equals to positive root 5, or x minus 2 equals to negative root 5. So what we get here, we're going to just add 2 to both sides for each of these equations. So I get x equals to 2 plus root 5, or x equals to 2 minus root 5. Okay, so where you're drawing this, these are obviously surds, so you can put it in your calculator to get a rough idea for where it is. But this value is going to be around here. And especially when you get surd answers, you want to label them in. So this one's going to be 2 plus root 5. This one's going to be 2 minus root 5. And now I just connect the dots. I'm trying to draw a continuous curve. Let's try that again. And I'm going to go up. And I will draw this point a little bit closer just so that the graph connects. So sometimes we won't get nice answers. Remember, quadratics don't always behave nicely. We may get surd answers. So it's important to, if you have those, just really show them and label those for the x-intercept on your graph. Now moving on, got a couple of examples with some non-mnemonics. So what we want to do is we want to complete the square. So I'm just going to factor out 2 first. So I get 2 outside of x squared minus 6x plus 8. I'm going to bring the 2 over to the other side. So I get y over 2 equals to this thing over here. And before we even do that as well, I can get a feel for where my y-intercept is going to be roughly. I sub in 0 for my x values to get the y-intercept. That's going to be at about 16. So this graph obviously isn't to scale, but we're just trying to get a rough picture. We're getting a rough sketch, seeing what is happening here. Now, we're going to complete the square on the right-hand side. X squared minus 6x plus minus 6 on 2 squared minus 6 on 2 squared plus 8. And this will simplify down to y over 2 equals, this will be 9. So this will give us x minus 3 squared minus 9 plus 8 gives us minus 1. And then we have to multiply the 2 over again. So I get y equals to 2 outside of x minus 3 squared minus 2, because that multiplies to both of these ones. So now that I have it in this form, I can read off the vertex. The vertex is going to be 3, negative 2. So that'll be about here, because this isn't to scale. Let's do it down here. And now I just have to find my x-intercepts. So I set y to equal 0. Everything's on the right-hand side. I can add the 2 across and then divide by this 2. So that'll give me 1 equals to x minus 3 squared, I take the square root of both sides. So one option is for me to have x minus 3 equals positive 1, or x minus 3 equals negative 1. And my solutions are for my x-intercepts, x equals 4, or x equals to 2. So I have these ones here. I want to draw it in. And now I can connect up all of these. Now that I have all my significant points, I can just draw a line through. Smooth, continuous curve, passing through everything and going back up. And there is my graph. I've completed the square. I have used that form, my vertex form, to find the vertex, calculate the y-intercept as well as the x-intercepts. These are the 4 key points we need in this case in order to be able to draw our graph. Now, one last question that we're working through is, this is kind of looking at it from a different perspective. Now, here it's telling us that the quadratic has a vertex at -3, +2. So it's saying find its equation if these two options. So the first one tells us that x equals to 5 is one of its zeros. So before we do anything, we need to imagine what this would look like if we had it in the form y equals to a outside of x minus h squared plus k. So our h value here is -3. So this will be x minus -3. So the first thing I'm going to write, because we don't know what a is, we're going to leave that there. We need one of these pieces of information in this question in order to find that. But I can, based on knowing what the vertex is, write in these bits here. So that's my x-intercept, sorry, my x-coordinate, and the y-coordinate I add to the very end. So this is the general family of parabola that this one will take on. And now we want to use this bit of information to find what this a is. So it's saying that x equals 5 is one of its zeros. So that means that we can substitute, that means one of the x-intercepts is 5. So we can substitute the point 5, 0 into the equation. One of its zeros is 5, so that means an x-intercept is 5. That will be the coordinate of 5, and then obviously the y value is 0 for an x-intercept. Now, we know that the graph passes through this, so we can substitute this in for the x, this in for the y, and it becomes an equation that we can solve. So substituting this in, I get 0 equals to a multiplied by 5 plus 3 squared plus 2. And what that's going to give me is, you can pop this into your calculator, but we can just rearrange this. So -2 goes over here, and I get a times 64. So a is going to equal to -2 over 64, which simplifies down to -1 over 32. So that is my coefficient a. This is by how much the graph has been dilated. So my final equation for this one, under this condition that x equals 5 is one of its zeros, this is going to be y equals -1 over 32 outside of x plus 3 squared plus 2. Now we're going to take that exact same idea, but we are going to look at a different condition in part B. Now this is telling us that the coefficient of x is equal to 1. Now, the graph belongs to this same family, okay? So I can write down that one again. It's going to be in this particular form. We just want to find a for a different condition. Now, we know that this currently in this form doesn't give us the coefficient of x because we want to expand this out first. Now, if we were to expand this out, this would give me y equals a outside of. In here, I'm going to get, if I expand this perfect square, I get x squared plus 6x plus 9 plus 2. So I'm going to expand this section here. because that is going to give me a coefficient of x. So I get y equals to ax squared plus 6ax plus 9a plus 2. That means my coefficient of x is 6a. Now I can use this information. It's told me that the coefficient of x is equal to 1. So I'm going to say that 6a equals to 1. Therefore, a has to equal 1 over 6. That is my coefficient now. I can substitute it back in. So I get y equals to 1 over 6 outside of x plus 3, all squared, plus 2. So this is how we can apply everything that we've been doing to some harder style questions, as well as for graphing these quadratic functions. But that brings us to the end of the video. Thank you so much for watching, and I'll see you next time.